Hi students, today we will discuss the concept of force. Force is first conceptualized by Galileo. So he used a very interesting term to define force. What he used the term to define force is interaction. So force is basically this term, interaction. So whenever any system interact with another system, the system develops a physical quantity, a vector quantity called force. Okay. Now there are a lot of physical characteristics that is explained by Galileo, and later Sir Isaac Newton has conceptualized all the properties of force into three laws, and the laws are famously known as Newton's laws. So Newton's first law says that if a body, suppose this is an horizontal plane and here is a particle or a body which is initially and finally and at every moment at rest, under what condition this body will be at rest? Provided there is summation of external forces, the resultant of all the forces that are acting on this body must be equal to null vector or 0 bar. And if these forces resultant is 0 bar, then also there is another possibility that the body may move with a constant velocity. So there are two possibilities. If the net force acting on the particle or the body is null vector, the net force is 0, then the body will be either at rest or moving with uniform velocity. Now let us go to Newton's second law. Newton's second law says that it is just the reverse of the Newton's first law. In case of Newton's first law, the net forces summation is how much? It is supposed to be null vector. Here, if the summation is not null vector, if it is some non-zero value. So in that situation, the external forces being non-zero, they are also called unbalanced force. That unbalanced external force is directly proportional to rate of change of linear momentum with respect to time, and the direction of this external unbalanced force and the momentum vector will be, the change of momentum vector will be parallel. So whatever be the direction of the change of linear momentum, in that direction the resultant external unbalanced force acts. So this is Newton's second law. Now let us come back to the most important law, the Newton's third law. Newton's third law is saying that the action acting on a body, which is a force obviously, and the reaction acting on another body, which is also a force, must be equal in magnitude, but because they are opposite in direction, there must be a minus sign. So action and reaction acting are always equal in magnitude but opposite in direction. And the next concept on this third law is that the action, if it is acting on say body 1, the reaction can never act on body 1, the reaction will act on body 2 or some other body. Means action and reaction can never act on the same body. And the third part of this law is the cause of action, the cause, the reason why the action has come, and the reaction must be what? Same. The cause of action and reaction has to be same. So for example, if this is earth, say here it is a particle I have released and the particle has mass m, so it is interacting with earth's gravity with a force mg. So this is an action, right? This is mg. So where the reaction acts, the reaction will not act on this particle, but it will act on the different particle which has caused this action, and which has caused this action, this mg, it is the earth. So the reaction of mg is equal in magnitude but opposite in direction and acting on earth. So this is Newton's three laws, one of the most important laws in physics. These are the building blocks of physics. I hope you have understood the laws. Entire physics, the discussion of physics, this is the foundation of physics. So I hope you have really liked it, and do subscribe my channel. Thank you for watching. See you in the next video with numerical on first law, second law and third law. Ta-ta.